Alright, today we're going to learn how to do Venn diagrams that happen to have three categories, which makes three circles, and different kinds of ways using combinations, or NCR, that have grouping with them. So, let's get started with the presentation. Let's do the first example. This is going to be an example about a Venn diagram that's going to have three circles. So, let's suppose we have a parking lot that has 227 cars in it. 47 of them are Fords, 58 are colored black, and 12 are convertibles. Furthermore, 14 of the cars are black Fords, and 5 are Ford convertibles. And 2 of the cars have all three attributes. They're black, and they're Fords, and they're convertibles. So there's two questions we're going to want to answer. How many of them are Fords but not black, and how many fit none of the three descriptions? So first, let's put the information into a Venn diagram. So 227 cars is out here, the universal set. 47 are Fords, means this circle here has 47 elements in it. This circle is a circle of black cars that has 58 elements in it. The circle down here is a circle of convertibles, and that has 12 elements in it. Okay? 14 of the cars are black Fords. Be careful where you put that 14 when you're making this Venn diagram. I like to put it pointing here, which means this entire football shape contains 14, because those are the black Fords. Not just this bent triangle shape here, but the entire football. Because let's look at what it says. 14 of them are black Fords. And if you're black and a Ford, then you're in here, both of these areas. So 14 makes up both of these. Of course, that means this upper one is going to be 12, but we'll get to that later. Okay, and then 5 are Ford convertibles, and similarly, here's Ford, here's convertible. So 5 is this entire football-shaped region. And 4 are black convertibles, which means this entire region here is 4. That's why that's indicated that way. 2 have all three attributes, black and Ford and a convertible, and of course that goes in the middle. So now we can fill in all the other shapes. As I said before, if the black and Ford is 14, and we know that the middle section is 2, then that has to be a 12. Similarly, if all of this is 5 and the middle section is 2, that has to be a 3. If all of this is 4 in the middle section of 2, that has to be a 2. So now all of the shapes in the three circles have been filled in. We can figure out how much is in this entire union of the three circles by adding up 30, 12, 42, 3, 2, 2, and 5. All the small shapes can be added up and realize that the union is 96. If there's 227 cars altogether and 96 of them are in the union of these three attributes, then the outside here is going to just be the difference between those, or 131. As you can see labeled here. So let's answer the questions. How many Fords are not black? Well, these are Fords that aren't black, and these are Fords that aren't black. This entire circle is Fords. This circle is black. So if we're looking for Fords that are not black, here are some, and here are some more, for a total of 33. And how many fit none of the three descriptions? They're not Fords, nor are they black, nor are they convertibles. 131 of those. So that's the end of the first example, and that just shows you how to do one kind of three-circle Venn diagram. The next example is going to be a different kind of three-circle Venn diagram. In this example, we say that we surveyed 117 people and talking about business magazines they read. These are people who are business people working in companies, and so they were asked about Business Week, the Journal, and Time. So we learned that 88 of them read the Journal, 76 of them read Business Week, and 85 read Time. 42 of them read all three, and 6 among these 3 read only the Journal, 5 have only Business Week, and 8 only Time. So the question here is how many don't read any of those 3 magazines. And once again, let's put the information in the Venn diagram. So here is all the information that we were given of, this actually should say 117 up there. Here's all the information we were given, 117 people total. And here are all the numbers filled in, 88 for the Journal, 76 for Business Week, 85 for Time, and 42 in the middle for people who read all 3. And that's all we're given. It seems like there's a lot of information missing, and we'll see what we have to do about that. Well, what we do is we define three variables for these three regions that we don't know, A, B, and C. And then just simply by adding up all the different elements in a particular circle and making it equal to the total of that circle, we can write three equations. So 6 plus A plus 42 plus C should equal 88. And you can see that right here. And then you get A plus 5 plus B plus 42 equals 76. And down here for the time circle, 8 plus C plus 42 plus B equals 85. So here you can see we've written three equations in three unknowns. Now we solve them, and of course we know how to use matrices now. You could also use substitution or elimination, any method you'd like. It boils down to these three equations, and the answers are A is 17, B is 12, C is 23. So we fill these numbers in, 17, 12, and 23, and again we have the entire three circle shape filled in. So it's time to add up everything in the union, these three, the next three, that, and we get 113 elements in the union. Well, since there's 117 people total who were surveyed, that means we just do 117 minus 113, and there's 4 people out here in the outside area, and 4 people do not read any of the magazines. So that takes care of the two different types of three-circle Venn diagram problems you might see. One where you just merely need to work and fill in the different shapes, and another, which is this recent one, where you actually have to make a system of equations and solve it. All right, now let's move on to the third example, which uses combinations, but uses them in a way where the elements you're looking for have been grouped into different groupings. I'll show you what I mean by that. So say you have a class of 23 students and it's broken up to have 14 boys and 9 girls. So now the principal is asked to have 5 students go help out. And so you're going to choose 5 students from this group. And how many ways can you get 3 boys and 2 girls if you choose 5 students? Another question might be different situations. Suppose you have 4 students to do a video conference. And how many different ways might you get 2 boys and 2 girls out of that group? We're going to use combinations, but we're going to have to see how many boys, how many girls, and use that and sort of break up the way we compute the combinations. And I'll show you how that goes. So for the first question, if you're choosing 5 students and you want there to be 3 boys and 2 girls, since you have 14 boys and you're choosing 3, you do 14C3. Since you have 9 girls and you're choosing 2, you use 9C2, and then you multiply those two numbers. You multiply them because you're not really done choosing after you've chosen the boys. You also still have to choose the girls. You're building your way to a final solution, and any particular option of how you're choosing boys has all those different options for how you're choosing girls. So this is definitely an example of the multiplication principle. So we multiply the 14C3 times the 9C2, and you can tell there are 13,104 ways that you can get 3 boys and 2 girls. Now, if you want 4 students with 2 boys and 2 girls, the math looks very similar. 14 choose 2, that has you get your 2 boys, and 9C2, that gets you your 2 girls. Multiply those two together, and you get 3,276. So those are 3 examples with the new topics for today, and that should be enough to get you going on the problems you've been assigned. So good luck on those, and we'll see you in class.